right, folks, this is Notes 1.5, Divisions of Segments and Angles. In the spirit of full disclosure here, this is the third time that we are recording this due to different technological issues. So if you feel like e-learning, remote learning pushes you to your limits, I get it. But, they say third time's the charm, so here we go. So what we're going to do in this section is talk about a really important topic, which is the notation, the vocabulary, and how we use and talk about dividing segments or angles into congruent pieces, congruent segments, congruent angles. So we're going to walk through some different vocabulary and then we'll look at some examples as we finish. So the first definition here, we're going to start and focus on division of segments. And the first definition that we are going to look at is the definition of a segment bisector. So here we go. I want you to notice the if-then structure. Remember that definitions are reversible. So our first definition, if a point or segment, ray or line, divides a segment into two congruent segments, then it bisects the segment. So the word for dividing a segment into two congruent segments is, and the point, segment, ray, or line that does it is a bisector. So any of those can cut our segment in half, but specifically if we talk about a point and a point bisecting a segment, we have a special name for that, and that is our definition of a midpoint. So looking at our next definition here, it says if a point divides a segment into two congruent segments, then the point is called the midpoint. And you've probably seen midpoints before and worked with them. Another way we think about midpoints is the point that divides a segment in half. So it divides it into two equal measures, or in our geometry notation, we're really going to focus on saying that it divides it into two congruent segments, and then we know all of the ideas about measure being equal come from there. So first, looking at example number 1, it says, if B is the midpoint of segment AC, what conclusions can we draw? So I want you to stop and I want you to look at this and I want you to think about everything that we can conclude and all of the conclusions we can make. And if I've done this video right and if it is an Edpuzzle, then there will be a question right here, a multiple choice question that's going to have you answer before you move forward. So if so, answer that question now and then we'll talk about these. So a couple of things that hopefully you noticed. The most direct conclusion of a midpoint, if it says B is the midpoint of segment AC, that means that two pieces of AC, AB and BC, are congruent. So that means a main conclusion is AB is congruent to BC. But also, as we talk about our notation, we could also say that B bisects segment AC. That is also an appropriate conclusion if B is the midpoint. B bisects AC. And then also, looking here, the points X, Y are along a segment that contains B. So that means that the segment XY containing B also passes through that midpoint. So that means it also bisects AC. So that means XY bisects AC. So that means here that AB and BC are congruent. Now, big thing to remember, we don't know anything about XY. I have no clue if where AC crosses through XY, it's cutting it in half. They didn't tell us that, so we want to not assume it's happening unless we have that information. So next, we can divide an angle into two congruent segments. Let's also look at what happens with another scenario, which is trisecting a segment, that prefix tri meaning 3. So here's our definition. If two points or segments, rays or lines, divide a segment into 3 congruent segments, then the points are called trisection points. So trisection points are 2 points or that divide the segment into 3 congruent segments, or if we're working with segments, rays, or lines, we could say that they trisect the segment. So let's look at another way in which we're going to see these show up. So example 2 says, AR, if AR is congruent to RS, is congruent to SC, what conclusions can we draw? So boom, 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 3 tick marks for 3 congruent segments. So looking at segment AC, we have points R and S that are at our split here. So points R and S are inside of AC, and that's exactly our boundary line between where this is trisected. So that means that we could conclude that R and S are trisection points. Or another way to say the same thing would be that R and S trisect AC. And one thing I'll add to that first line to make it a little more exact is R and S are trisection points of segment AC. So these are all of our vocabulary words to talk about dividing a segment into two congruent pieces or three congruent pieces. So bisect and midpoint go with two sections. Trisection or trisectors are 3 points. So one thing I want you to think about before we move to talking about division of angles is so far I've only talked about dividing segments. If you think about rays and lines, is it possible to find the midpoint of a ray or a line? So I'm going to tell you that no, it is not possible. So again, I'm going to now pose, if it's not possible, why? Can you give me an explanation for why a line or a ray cannot have a midpoint? Again, if we're an ed puzzle and everything's working correctly, hopefully there will be a question here for you to put your thoughts so I can see those, and then we're going to move forward to our division of angles. If this is an ed puzzle, just ignore these little notes here and just keep watching the video. So next up, we are going to talk about angles. So let's go ahead and switch colors. This nice purple. So you're going to find there is very similar vocabulary for angles and segments. That's why we want to be extra precise as we're working with this. So for an angle bisector, here is our definition. If a ray divides an angle into two congruent angles, then the ray bisects the angle. And the ray that bisects the angle is called the angle bisector. So the ray that bisects an angle is an angle bisector. In this case, we will only have one option. Angles can only be bisected by rays. So next here, to show you again how this notation can be used, our if statement says if angle ABD is congruent to DBC. So let's now use an arc to mark these angles congruent. Then, looking here, the ray that marks our division between them is ray BD. So that means ray BD is the bisector of angle ABC. Remember, the order for a ray matters, so it's not BD. All right, just like we can bisect and trisect a segment, we can bisect and trisect an angle. So let's look at our angle trisector vocabulary, and this is going to be our last definition for these notes. So for a trisector, here's our definition. If two rays divide an angle into three congruent angles, then the rays trisect the angle. And these rays are called angle trisectors. All right, so let's see and start to put this together and see how this all works. So here in our next example, it says if points B and C trisect segment AD, do ray EB and ray EC trisect angle AED. So looking at my trisection points, that is B and C, and they trisect segment AD. So something that is incredibly important because the phrase trisect or bisect could be used for segments or angles. You want to pay attention to what type of element is being trisected. That is a segment. So that means our most direct conclusion would be to conclude that the little segment AB has to be congruent to BC, which also is congruent to CD. So boom, boom, boom. So this is our starter point. This is what we know to be true. So now this means if I take those trisection points, those equal segments, and if I connect out to point E, does that guarantee me that these three angles have to be congruent? So again, I want you to stop. If you need to pause the video, do that. And I want you to think, yes, if you think it's yes, those rays definitely, because the segment's trisected, the angle has to be too. I want you to give me a reason or an example or some kind of supporting evidence for why you think yes. I want you to think about what that would be. If you think no, again, I want you to think of some reasons why. And the best way if you think no is to think of a counterexample. Try to draw a diagram or something that doesn't work to show, no, this is why this doesn't work, a case where it is not true. So now, if we were in class, we'd have a great discussion. It'd be awesome, but we can't because we are in a video. So I'm just going to go ahead and tell you the answer to this question is that no, this is not necessarily true. So the answer to this would be no, this is not true. When we come back to class, we're going to talk about this. My hope is that you are bringing your thoughts and your reasons. Now that I'm telling you this is not necessarily true, I want you to try to give me some counterexample or reason why, and we'll talk about this when we come back together. So let's look at a couple other ways this shows up as we wrap up this section. So example number 5 here says segment EH is divided by points F and G in the ratio 5, 3, and 2 from left to right. So quick thing here, these points are not trisection points because those ratios are not the same numbers. So we'll work this in just a second. It also says if EH is equal to 30, find FG, so that's find the length of FG because there's no bar on top of it, and name the midpoint of EH. So let's go ahead and mark our important information in this diagram. So one thing that should be easy to mark is EH is 30 units long. So I know this whole segment is 30 units long. So next up, a ratio. What a ratio is meaning is, so EF is 5 parts of the whole, FG is 3 parts of the whole, and GH is 2 parts of the whole. Altogether, those parts in those specific ratios or proportions will add up to the whole thing. So if you are not fully comfortable with ratios, one thing that I will plant in your mind that makes this an easier way to work this out is that I've used this word part. I have 5 parts, 3 parts, and 2 parts. We could guess and check and say, all right, what if I multiplied everything by 2? If I added those 3 numbers up, does that make 30? What if I multiplied by 3? Does that make 30 or 4? Sometimes it's not going to be an easy number or it might take work, so we want a mathematical foolproof way to figure this out. And the way to represent those parts is with an x. So that would make this 5x, 3x, and 2x. So now I have represented mathematically these ratios with a variable. Now we need to make some sort of equation, something that is true for the information that we have here. Well, thinking about this, these parts should add up to equal the entire length. So that means that each part added together needs to equal the whole thing, making for us an equation that should be true, that 5x plus 3x plus 2x is equal to 30. The parts added together equals the whole thing. So now we can add up our x's, adding those coefficients. That is 10x is equal to 30. Divide by 10, that gives us that our number of parts, x, is 3. So going back to the problem, for our different lengths, I'm just going to go ahead and plug this in and then we'll answer our question. So that makes EF 15, FG is 9, and then GH is 6. So for our first question, it said find FG, so the length of FG is 6. And then part 2, it said name the midpoint. So looking here, we want to ask, is one of these 2 points, F or G, the midpoint? And hopefully what you'll see here is that from E to F is 15 units. And then from F to H, if I add the 2 components, 9 and 6, that's also 15. So that means that F is our midpoint of EH. All right, there is another type of problem using ratios, using midpoints, putting this all together, the parts make the whole. We've got 2 more here before we end to show you different ways to use this, and then I will explain what's up next. For example 6, when we start to look at this, this might look like a proof. It says given, and it gives us some information, and we've seen this before in our notes that we did from section 1.4, but when you look at the very end, when we read it all the way through, it says find. Find the measure of OKM. This is your clue that this is going to be a more algebra-based problem. So you don't need to set up a proof. You can just set up the problem and work through the information that we have. So then let's do that. Our first given is that ray KO bisects angle JKM. So that ray bisects this angle. Now I can use the 2 arcs to mark those 2 angles congruent. Then I know that angle JKM is 41.37, so 41 degrees and 37 minutes. So this entire angle is 41 degrees and 37 minutes. So if this is bisected, it means those 2 angles inside have equal measure, And that means they have to add up to 41 degrees and 37 minutes, which hopefully will help us to get to the realization that if I took the total angle measurement for JKM and divided it equally in half, that would be the measurement of each of these two parts and specifically OKM that we're looking for. So let's go ahead and do that. So we have 41 degrees, 37 minutes. I want to divide it by 2. So specifically, we could take the degree section and the minutes, and we want to cut both of those in half. So let's see what happens. 41 degrees divided by 2 isn't going to come out to a whole number. That would be 20.5 degrees. Then 37 comes out to 18.5 minutes. So I have some degrees and some minutes. Cool. But this looks a little bit strange. We don't usually end up, and we shouldn't ever end up, when we're in degrees and minutes and seconds form, with a decimal. So we're going to do some regrouping, some reordering, and some conversions. I want you to remember, how many minutes are there in a degree? 60. So half of a minute would be the same, or half of a degree would be the same as 30 minutes. So I could take that 0.5, turn it into 30 minutes, add it onto the 18 minutes I already have. Same with this 0.5 minutes, half of a minute. That's going to come out to be the same as 30 seconds. So I could move that into a group and start a group with seconds. So putting this all together, this means the measure of angle OKM is going to be 20 degrees, 20 full degrees, and then 30 plus 18 is 48, so 48 minutes and 30 seconds. I can go ahead and put a box around that. And then something I want you to think here. The actual part of this problem that related to the section today, bisecting an angle, that was the beginning, just realizing we needed to divide by 2. I would say the heavy lifting of this problem was understanding degrees, minutes, and seconds. So if you didn't get a idea earlier on, they do build. So we want to make sure we have a really solid foundation as we keep moving forward. All right, our very last problem here is a proof, number 5. So let's look at how some of this shows up in proof, and then we will, when we come back together, do a lot more practice with this. So first, let's look at our givens. We are given that segment DH is congruent to HF. I have this nice little kite-like diagram here, and I'm trying to prove that H is the midpoint of DF. So segment DF, I am trying to prove that H is the midpoint. Okay, so let's go ahead first. Now that I have this information, thinking about what I'm trying to prove, in order to know what I need to have as a prerequisite, let's look at the definition. So going up to the top for a midpoint, the definition says if a point divides a segment into 2 congruent segments, then that point is conclusively a midpoint. So we're looking for a segment with 2 congruent segments proved here. Do we have that? 100%. We have DH and HF congruent. Those are the 2 parts of the entire big segment DF, which we want H to be the midpoint for. So we actually are going to have a very short proof today. It will be one step past the givens. So let's go ahead and set up our T column. On the left, we have statements. On the right, we have reasons. And then step number 1 is always going to be to state your givens. So if you're not sure where to take a proof, at least we can state our givens. Step 1 is DH is congruent to HF. And the reason to support that is that was our given information. So as we said, by the definition of a midpoint, all you need is to have stated before that the 2 pieces of that segment are congruent. That will be the information you need to conclude that the point in the middle is in fact the midpoint. So we can go ahead and jump to step 2. H is the midpoint of DF. So H is the midpoint of DF. Now, this is hopefully a step that stating our last step should feel okay. It's figuring out how to write and state our reasons that will take practice, and don't worry, we will do lots of practice and we will become much better at this as we go. So going back to our definition. So 1, make sure you know your definitions. If you want to make a sheet, we are just going to now write down the definition of a midpoint, but there's also some logic to help us remember. It connects to the line right before it, which was talking about congruent segments, and then we're trying to conclude that the point is a midpoint. So here we go. Here's our definition. I know it by memory, so I'm not going to scroll up, but you can scroll up as much as you need to. Here we go. If a point divides a segment into two congruent segments, these are our abbreviation, then the point is a midpoint. And that is our stating of the definition of a midpoint. And this is our conclusion of our examples in notes 1.5. From here, I want you to go into our folder and you will see a practice for the section that pulls a couple of short problems. They're meant to be A-level problems, the beginning introduction, and then as we come together, we'll work on some more advanced problems, some more multi-step problems, and you can ask questions as we go from there. So give these problems your best try, and then we will go over this more when we are back in class together next week. All right, that is it.